Now to Hamburg, Lukas, Haack, Head of Engineering, Suntrace, will present their project in Mali with the Fekola mine.
Thank you very much, Michael. It's a pleasure to be here. So my name is Lukas Haack, and I'm the Head of Engineering at Suntrace, an independent consulting firm based in Hamburg. So to me, the time difference to Augsburg is manageable. And I'm very excited to take you onto a journey to Mali, Western Africa, and more precisely to the Fekola gold mine. So what you're seeing in the picture is the powerhouse in front, which is using HFO generators for electricity supply of the mine. And in the background, you can see already the solar panels. And you get a glimpse of the battery system, but I will show more details. Right, so the project was implemented in 2 stages, basically. First, with a detailed feasibility study, where Suntrace, together with BayWa RE, developed the hybrid concept, the fuel saver concept for this application. And then the same team was contracted as an EP contractor by Beat Gold for the implementation. So we did the detailed engineering, we did the procurement, and we supported construction as well as project management. And currently we are working on the operation support. So we're still available to support operators on site for this initial phase, since project has started operation earlier this year. All right, let's have a more detailed look on the hybrid system. Now, the hybrid system, as I said, is mainly powered by the HFO generators. And these were also in place before. So we were hybridizing with a solar battery system to an existing infrastructure at the Fekola gold mine. Generator units have a total of 64 megawatts HFO and diesel, whereas the diesel is only used as backup. The load of the mine is approximately 42 megawatts, and the solar and battery system is a consistent feeding power into the grid as a fuel saver concept. The solar plant has 30 megawatts AC, 36 megawatts peak. It's a single axis tracked system. And the battery has a substantial size of 15.4 megawatt hours and 17.1 power. But its main purpose is to really smooth solar fluctuations throughout the day, keeping engines within the operating limits, providing grid stability service. The batteries are not used for load shifting. That's an important note here. Then the hybrid control system is enhanced by a forecasting device that predicts day ahead and near-term solar power output. This is first used for generator dispatch schedule to operators, providing recommendations when to switch on and off engines. And secondly, to detect any that may have been overlooked by the satellite-based forecasting and provide warnings to operators. Okay, now when we look at the fuel saver concept, we can see that on the right-hand side, the graph shows how the solar is basically replacing HFO in the system. And the way it works is you see the load is fairly constant for these kind of mining applications. It's basically providing power to main consumer 24/7. And when the solar starts producing power, it substitutes the HFO, and HFO engines can be switched off. Now, this existing system allows to switch off half of the engine capacity, and the battery takes the fluctuations, keeping engines within their ramp rates. And at the end of the day, operators are advised to switch on engines again to prepare for the night. Some of the project features I would like to point out are that with this system, we're saving 30.1 million liters HFO annually, which translates into 39 kilotons of CO2 emissions per year. It's a very project when it comes to economics. We are seeing a payback of about 4 years. And last but not least, it's one of the largest off-grid solar HFO hybrid plants worldwide that is in operation. Now, grid at Fekola is an island grid, which is not connected to the local villages. However, B2Gold had a different approach, and they were equipping the nearby village, New Falugu village, which is a 913 household strong village, with rooftop solar residential use. Further, it is expected that the existing power generation facilities will provide new business opportunities after mine closure, power availability. Basically, the repurpose of the generation facilities. All right, I would also like to share some experience we had with the operation of the system. So first of all, the fuel saving targets were exceeded. So currently the plant is in operation beyond the, or it's exceeding its expectations. Then the grid stability is improved, and basically consider the batteries as a spinning reserve replacement in your system. So it also allows you to enhance your redundancy concept. And it also takes care of keeping your engines in the comfort zone when it comes to ramp rates and sudden changes in the load. Also uses the genset running hours, which again reduces the maintenance cost of your system. One side note, the battery system and the solar is in principle capable to take over the power production and allow to switch off all engines, since it has a grid forming capability. But this can only be used during short periods, and of course when the sun is shining, considering that HFO needs to be kept in a hot condition. All right, now I would like to take some minutes to explain why I believe the renewable energy will become the new normal for these kind of off-grid mines. This was actually the title of the presentation, so I also need to prove why it is the title. So let's take some time to understand this graph. I can promise it will be worth the effort. So on the left-hand side, we see the cost, which is basically the LCOE. On the right-hand side, we see the renewable energy share, and the green line represents the RE share of the total energy production in 1 year. On the x-axis, we can see the renewable energy capacity in percentage of the mine load. So 40 megawatt mine load, 40 megawatt RE capacity, that's 100%. Now, the system we are looking at is 60% solar, 40% wind, and a battery that is also providing load shifting. The CapEx is shown in the blue line. It's not a CapEx, it's the LE, but it's based on a certain CapEx. And it's considered a cost reduction in the near and long-term future, mainly for the battery system, as it has a significant cost share when it comes to shifting. So keeping in mind the target emission reduction targets of the mining operators, hybridizing with renewables will be a stage-wise approach. And the first stage allows you to go to about 30% RE share at today's cost, lowering your overall LCOE significantly. So it's a very straightforward business case. In the second stage, assuming a price reduction of 20%, you could already go to 44% RE share. Still being in the optimum LCOE case, still having a very attractive business case. And what happens if we push this to the maximum? Now, if we get a very significant cost reduction, you would be able to get up to 80% of wind and plus battery hybrid system. Needless to say, that this is of course very project specific and very site specific. This was a fictive example. We did some calculations from Western Africa. But one point I'd like to point out is when you go for a break-even scenario, where your cost meets actually the current cost you have based on HFO, you could already reach 60% RE share today. So looking at the roadmap to zero, the lowest hanging fruit is indeed the electricity generation. And this is in particular true for off-grid mines, such as the Fekola mine. Secondly, the value drivers are the competitiveness of renewable energy and, of course, reduced carbon emission targets. Also interesting is you will be able to hedge energy cost for future operations with renewable energies. Just keep in mind, if gas prices, the graphs we saw before will change significantly. So let's hit the road.
Very good.
And the key takeaways from my presentation today, renewable energy has indeed become the new normal. Electricity power is the lowest hanging fruit to reduce the carbon emissions, in particular for off-grid mines. And 20%, which is the case at Fekola, is a proven case. And net zero is a stage-wise journey. Thank you for listening, and this is the end of my presentation.